Hello everyone, welcome to my channel. I have been trying out these LED dot matrix clocks for some time, which are displayed on LED matrix modules with MAX7219 chips. Each are built on different microcontrollers, coding platforms, and how they synchronize the time. I'm planning to make videos on each of these in series, and for today I want to show you this one. It is displayed on 8 LED modules and was built with a Raspberry Pi Pico W in MicroPython language. It synchronizes with NTP servers over Wi-Fi once every 24 hours. And we'll get to the code and the hardwares in a short moment. But first, here's a cool tip for newbies like myself. It'll help you not only in this project, but also in any similar ones. Here's a display module. It came with these pin headers, but they might better face inwards if we're planning on making a case. Also, because these sockets are not fully inserted, we'll have to fix that. But desoldering pin headers is no easy task. You can even ruin your PCB quite badly like this by trying to remove them by force. There are desoldering irons like this, but it still won't help much. To remove the pin headers, just forgetting about reusing them might be better. Here's how I worked with street pins. First, I pried the plastic holder from one side and pushed it outwards. For long ones like this, it's better to cut them short. You're half done if you've come this far. Now add fresh new tin to each pads to soften the old solder to help melting and removing them. After that, grab each pins with tweezers and pull them out while hitting from the other side. To clean up the pads completely, I used a solder sucker. Then I also applied more flux and wiped them with braids. Finally, I used 99% isopropyl alcohol to remove the flux. Back to the display module. Now the pins are bent ones. I just cut them off at the top with an end cutter. And the rest will be the same as the street ones. Plastic is removed first. Pinch the pins out. Remove the tin. clean with solder wick. Finally, a new set of headers are in. And wiped off the flux. Next, we have these pin sockets. The process was the same. Cut off the legs. Remaining pins were pinched out while heating. Tin got removed. And new sockets were soldered. I'm checking if it is fitted properly. Before soldering the rest of the pins. Finally, a flux cleanup. After that, I joined two of these to make an 8-unit module. Short wires were bent to the U shape, and then I connected the solder pads. Each joints were soldered. And I cleaned the PCB. Now I need to connect it to the Pi Pico. Here's a Pi Pico with its pinout. And here is the display module. First two are power and ground. These are to be connected to the Pico like this. The Max 7219 modules work on what's called SPI. And there are two signal lines for running the SPI protocol, CS and the clock. And I connected them to SPI 0 pins on the Pico like this. Finally, there is a line for data. In this case, this display module has only one line to receive the data. So we need to connect it to the TX pin on Pico like this. In the code, I have to correctly identify the pins in use. Here, I'm using 2, 3, and 5 for clock, TX, and CS. And the channel is SPI 0. I should remember that. Let's try that for real. Please look at linked above for making a custom cable like this. First, the power and the ground. Now the data into GPIO 3, CS to 5, and the clock to number 2. On the other side, I just check the correct direction. And here it is. Alright, let's write some program in Thonny. Among the libraries that I used, this last one has to be brought from the GitHub shown here. These are Wi-Fi credentials for my home, which you'll have to change with yours. UTC offset is set in seconds, so for Korea, it's 9 hours times 3600 seconds. After that, there are pin numbers. In the first line, there are SPI channel number, clock pin, and MOSI GPIO pin numbers. MOSI, or master out slave in, refers to the TX in the previous diagram. And CS pin number is in another line. These lines are for preparing the display. Here is the number of module units. There's brightness, and this line clears the display. I wrote two functions for this program. First one is for display refresh, which shows the string passed on as the argument. To display a text, you first set the text, and then with this line, the display actually shows it. Next function is for clock synchronization, which happens at the beginning as well as every 24 hours. I placed these message displays to let me know when this happens. In this try loop, the program will try to read time from the internet and set Pico's internal clock. It happens every 2 seconds until it successfully synchronizes the clock. When successful, the time data is stored in this now tuple, and the time string is formatted into a string, which is to be passed on to the display refresh function we've shown above. Moving on to the startup process. Wi-Fi is activated and connected with the credentials above. It tries to connect again for 10 times until the Wi-Fi status shows connected. After Wi-Fi connection, the clock sync function is executed, and the timer is activated to resync every 24 hours. In the while true loop, the time is read from the internal clock, formatted into a string, and display refresh is performed. I set up a little bit of delay here because the display doesn't have to be refreshed so often. And that's it. Let's run it with our Pico and the display. You'll be watching the startup sequence in a moment. And there you go. After the test, my final code got some updates. I added delay argument to the display refresh function so that there could be some delay, for example, half second here, to leave a message displayed and could be read. Otherwise, in a normal loop, I reduce the delay. So it is how it's done out of codes from many different sources. I wish I could change or transform the font, but I couldn't find an easy way for it in MicroPython. Anyway, this result was a basic one that does the job, which is what matters, I guess. Please come back again for other clocks with different approaches. Bye for now, and thanks for watching.